mechanical properties distribution. So we have studied so many mechanical properties like toughness, hardness, brittleness, ductility. These are all the properties of any material which to be used in engineering applications, right? So imagine you are making a boat. You all know what is metal, right? So when you have watched the film, what happened to that boat? It went and hit an iceberg. Then it broke into two pieces and then drowned. So many people died. This has happened in the year 1912. Okay, the reason for that accident is materials. The property that should avoid this collision between iceberg and boat. So iceberg is so strong, so that boat is so weak. So if it is so stronger than iceberg, there will not be any accidents happen. So that is the property we are going to test it here in this machine. Okay. For example, you take any material, you see the surface. Surface is very important than subsurface. This is surface. This is subsurface. Okay. So this subsurface will have certain properties, but the surface should have superior properties, so that there is no abrasion or what we say when you scratch something, when you beat the fiber here with some scratches, then the strength of the material goes down. So hardness is the ability of the material to resist abrasion. In detail or in very simple language, if you want to know what is abrasion, you would have played some small play in your classrooms, keeping your compass and chalk piece, right? So compass, if you scratch it, chalk piece, what will happen? Powder will get out. What is the reason for that? Chalk piece is harder or compass is harder? Which one is harder? Compass. Because compass is more hard than this material gets damaged. The same way, we are going to have a diamond ball indenter in this particular setup. We have a workpiece here. So when you load this workpiece, the diamond indenter presses this workpiece here, there will be a dip. So it depends on the hardness of the surface. Okay? Large bit or lower bit. So we have different kinds of hardness for all the materials like aluminum, steel, copper. We use two hardness distributions. One is Rockwell hardness distribution. Another one is Brinell hardness distribution. We have one more hardness distribution when the load is higher. Okay. So we have a scale here. One is A scale, B scale. Based on the scale, we can select the indicator as diamond or something like that. Okay. So here you have something called application. So what material you are going to test? Based on the material's application, you have to select whether you have to select A scale or B scale. We have both the scales. A scale is black one and B scale is red color one. So this is, we are finding the hardness number. Every material will have one hardness number, Rockwell hardness number or Brinell hardness number. Okay. The procedure to do this experiment is just lower down this anvil. Okay. Just keep the surface that is exposed to the diamond ball. Then you start loading this until it touches. So when it touches, the dial starts moving to 0. Okay. So after getting it to 0, you have to increase the loading. Whether you are selecting the load, here we have something called as load selector. So we have 100 load. We have. Okay. If you rotate this, then you can select the load. You have to apply whether A scale or B scale before selecting the load, so that the indenter goes down and then makes a impression. way we are going to find out hardness. You understood what is hardness, how this hardness crystal works, and what is the scale. This is called Rockwell hardness.